Welcome, software engineers, to day 11. We're a third of the way through CSC 222 software engineering. Thank you for joining me. Thanks for being connected via Zoom. Thanks for being here on time. I appreciate all those things. Wally, I'm designing a suite of internet collaboration tools. It's part of my long-term goal to eliminate all forms of direct human contact. That's messed up. You're exactly what I'm trying to avoid. Well, I'm sorry that we have to avoid human contact, but I guess that's the way this class is going to be, right? Exam number one, wow, was really impressive. As a class, you did great. I mean, when several people got more than the possible points, how's that possible? Well, there was extra credit on there too. You were just doing fantastic as a class. The highs were very high. The average was very high. So good for you. Here's the distribution. I think for the most part, folks are doing really well. I do want to talk just about a couple things with the exam. If you have a general question, feel free to ask. You have a specific question about your particular exam and maybe any feedback there, I'll be happy to talk with you. The short answer ones, I gave pretty cryptic feedback just because I knew I was going to talk about them to everybody. So if I said something like purpose or why or what, you'll see that in just a minute. By the way, the true false multiple choice, man, there was not a lot of difficulty with those. I usually try to share any questions where, less than 2/3 of the class got the answer right. And of all the true, false, and multiple choice, there were only two questions when less than 2/3 of the folks got it correct. So, but you have to have a couple hard questions, right? How do you separate the A pluses from the A's? Psst, what's 7 plus 6? 300 billion gazillion. Oh, thanks for the big help. That's a 3 followed by 85 zeros. I knew that. Miss Wormwood was going to give me a D- on my paper, but I talked to her after class and told her how I ran out of time and couldn't write all I knew about Tyrannosaurs. She said I had plenty of time to do the assignment, but she admitted that maybe I picked too complex a subject. So she raised my grade to a D and told me I should try to pick realistic goals and plan my time better. I guess we learned a lesson, huh? I'll say smooth talking the teacher really pays off. Folks, I'd give you numbers, but Blackboard, and I told it to do this, Blackboard changed the order of all the questions. I've decided that just makes my life harder trying to find the short answer questions in it. Blackboard should have shown you everything at once so you could have scrolled forward and backward. I should have mentioned this beforehand, but as an exam taking strategy, don't feel like you have to do things in the order presented to you. Feel free to go through there and do those ones you know well instantaneously right away. Sometimes it's a good idea to start with a short answer, sketch out something, and then go back and do the true, false, multiple choice, because sometimes you'll see something in those questions that will relate to the short answer, or something will key off your brain and say, yeah, I should talk about this in that one there. All right, 2 true, false questions I want to focus on. One said, a prototype helps users and developers visualize the internal algorithms. False. A prototype is the external view. Prototypes don't even work. There's no algorithmic processing in a prototype. And beyond that, users could care less about the algorithmic processing. Prototypes are the external view in the idea phase of software engineering. It allows us to communicate with the client and user and say, does this look like what you're thinking? Exactly. So prototypes have nothing to do with algorithms, and users don't care about algorithms. That was false. Another true false question that tripped up some people was, 2 problems with informal specifications. So you had to know what an informal spec was. Informal specifications are those written in a natural language like English. Informal specifications are the documents. So 2 problems. Number 1, they are graphical in nature. And number 2, they violate the milestone principle. That's false. First of all, they are not graphical in nature. The graphical things are what we call semi-formal or structured techniques. The UML diagrams, what do we do? Use case diagram, and then the data flow diagrams. Those are less ambiguous, more formal. But informal ones are not that. And secondly, violate the milestone principle. Those are just words. I just made stuff up there. The answer was the short answer questions, at least the 3 that you're required to answer. And I should say, extra credit you do not have to answer, but I'm glad to say, I think nearly everybody gave all those a shot. So good for you. One of the benefits, I think, of doing an exam on Blackboard, at least I've noticed because I've been doing exams for a long time. For whatever reason, on paper exams, sometimes people would forget to do, they forget to do a true false. Everybody did every question. Good for you. Don't know the answer? Guess. Absolutely. All right. Short answer. Number 1, what is software engineering? Consider what, why, and how in your answer. I warned you up front. You should start by saying software engineering is the management of the entire software development process, but don't end there. Okay, so what is it? Management of the entire software development process. You could have also said it's professional problem solving. That's good. You could have also said it's programming in the large. That's all part of the what? All part of the what? So that was 1 out of the 5 points. Why? Solve problems on time, within budget, and function correctly. Solve problems on time, within budget, and function correctly. Another thing you could have said about why. It's a management tool to manage, and then list some things: resources, time, cost, developers, technology, expectations, all those things we say. And the third aspect of the why is software engineering is a response to the software crisis. So you gave me 2 of those 3 major points, then I thought you knew what was going on there, and that satisfied the why. Solve problems on time, etc. Manage some things, and this is a response to the software crisis. The last aspect, how? How do you do software engineering? Yeah, the framework of the software development lifecycle. I really wanted you to say software development lifecycle, or abbreviated as SDLC. And what's the point of that? To monitor progress. Additionally, you could have talked about the use of milestones, markers of progress. You could have, some people said, well, software engineering is part art, part science, part algorithm, part heuristic, part creativity. Right. Communication via documentation, diagrams, etc. So how? Framework of the software development lifecycle to monitor progress. Use of milestones to mark our way. And yeah, part algorithm, etc. Fine. But then the other big thing of the how, of course, is communication. Requirements and specification, which we'll talk about in a moment, are all about communication. Good. So you gave me the what and a couple things about the why, a couple things about the how. That was full credit. You got partial credit, and depending upon exactly what you wrote. Another short answer question. What is the purpose of the requirements phase? What is produced and why? So purpose. Understand the problem. Understand the problem. Another way of phrasing that is understand what's needed to solve the problem. Now, two things you really should have said. This focuses on the why questions. Requirements is all about why. Why is there a problem? Why is a computerized solution needed? And the other thing, for a computer scientist, we focus on the outputs. The outputs are the information needed. Right? So that's the purpose. Good. Couple points there. What? Well, three things specifically are done. If you said a document and a prototype, that's probably good enough. Problem definition document, a requirements document. We separate what and why the problem from what and why a computerized solution is needed. And then a prototype. Prototypes are produced here for communication. Why? We prove the problem is understood. The reason we do the requirements doc is to prove to the user, prove to the client, prove to our boss that we really understand the problem. That's what the document and the prototype are all about. Good. Now do the same thing for the specifications phase. What is it? What's its purpose? What's produced and why? The purpose is to determine the features and functions of the product. Features and functions are slightly different. Features are the outward facing things. That's the button and the boxes the user sees. Whereas the functions are the code behind those features. So it's okay to lump them together. And it'd be okay just to say it's the features, it's the functions of the product. Either one is fine. In addition to determining the features and functions, we determine what this product looks like. What does it look like? And that's based upon a prototype. Now, focus. The key question for specifications is what? What are the features and functions? What does a good product look like? What does a good product do? And for computer scientists, we're focusing on the inputs and the outputs. Here we determine both the inputs and the outputs. Great. What's produced? Three things: a specifications document, a planning document that includes estimates of time, budget, acceptance criteria, etc., and a prototype. Give me at least one of those things. Why? To prove that the proposed solution is appropriate. Not just that we understand it, that was requirements, but to prove to our client and user and boss that the proposed solution is appropriate. And this is all about communication. Good. There were a couple extra credit short answer questions. List and explain the three major problems with software development. This is what I call the unholy trinity. Software development's behind schedule. Software development's over budget. Software development is full of bugs. Now, that's the list. Explain it a little bit. You're saying, well, behind schedule, it's late. It's not, realize we're not saying it's just, well, it takes a long time to do it. What we're saying is we estimated it'd be done in 3 months. And here it is 6 months later, and we're not done. Good. And the other one was according to me. Now, if you just made up your own aspects of professionalism, that's fine. But we've talked about 4 that I've mentioned to you: being dedicated, being civil, being on time, being a team player. So would you give me one of those and explain a little bit? Then you were set. And thanks for doing that. Oh, well, I'll just leave it here. If you have a general question about the exam, you can ask now in chat or unmute. If you have a specific question, maybe about your exam or whatever, yeah, either stay after class or shoot me a message and let's chat about that. Okay, good. In general, you're doing great. Thank you. Good for you. CNCS4 is due today. Christianity and computer science, that was due today. That somehow slipped by you. Please do it quickly. I want to grade these things all at once in a batch. And it happens tomorrow. Coming attractions, what will happen in the future? Question, what's the purpose of the specifications phase? The stated purpose of the specifications phase is to determine the features and functions of the product, determine what a good product looks like and does, focusing on the what questions. And computer scientists, we focus on inputs and outputs. Sound fair? Good. Now today, two things. We're in the habit now because I'd been doing this on a Monday, but then Labor Day, so we switched to a Wednesday. So week to week, Wednesday to Wednesday will be a CNCS assignment. Today we'll begin talking about a new aspect of professionalism, and we'll finish it up on Monday, and then by Wednesday you can connect that to the commandment. These do not have to be long and involved. Some of you are writing really good stuff, but it doesn't have to be a page. I'd rather it's not a page. Half a page is plenty. Thank you. And the other new thing, just because I'm never sure the Blackboard is showing you this or not, assignment 13. And yeah, you've noticed that my numbers are kind of off here, but that's because I just don't want to go back every time I make a little change in that's not enough. Yeah. Just trying to change the numbers here for the assignments. Blackboard doesn't like that. So don't let it bother you that there wasn't a 12. We'll talk about assignment 13. This is another sprint, another aspect of our individual add numbers project. Okay. So look for those on Blackboard. And by the way, when you take a look at Blackboard, up until last time, up until Monday, that was Unit 1. Now you'll find everything beginning today until the end of October under the link that says Unit 2, because that's where we are. We're in Unit 2. So we better, as Zeb would say, we have a giant squid to catch. And Zeke chimed in, yep, let's get cracking. Let's get cracking. Let's get cracking. All right, let's get cracking. Unit 2 of software engineering, the implementation phase. So Unit 1 was the idea. 2 major phases of software engineering under idea, requirements and specifications. Now, please don't forget about those, because when we get to our team development thing in a week or so, we're going to go back. And as a team, you're going to create requirements and specifications for whatever it is you're doing. Okay, but we got to move on. Implementation. What's the purpose of the implementation aspect here? To instantiate the idea. I'm sorry, I just happen to really like that word. It's one of my favorite computer science related words, instantiate. Thankfully, you see, I gave you a definition right there. To instantiate is to represent something like an abstraction by a concrete instance. So now we're going to take our abstract model of the software, the idea of it, and we're really going to make it. Instantiate the idea. Wally, my contributions can't be measured by the number of hours I work. I'm a man of ideas. One great idea is worth more than all of you put together. Fine, let's hear your great idea. You just did. Ideas are important in anything, including software engineering. But you can't stop there. I'm sorry, you can't be Wally. You can't just be the idea person. At some point in time, you got to get the ideas out of your head or the abstract representation in graphs and paper into a concrete thing, into an actual real system. Hey, we didn't start this way today. You were concerned. You thought that maybe I had forgotten. Software engineering can be described as professional problem solving. So let's move on to our fifth aspect of professionalism, being cool and calm. Now, that's a colloquial phrase. If you're not a native English speaker, it has nothing to do with being in cold weather, Wisconsin. It describes your attitude and your actions, being cool, calm, and collected. If you have a better term, I'd love to use it. You can suggest a better term for any of these things. A long time ago, I used to call number one being committed. But then somebody said, that sounds like being committed to a mental institution. And I said, okay, how about dedicated? You have something for cool and calm? I'll take it. This is an aspect of professionalism. This is no surprise. I'm going to relate each of my aspects of professionalism to one of the commandments. Fifth commandment. Now, I think I said this before. If you're a Christian but not a Lutheran, you may number the commandments differently. Not every Christian group numbers the commandments the same, because when you read it in Exodus 20, God does not say, and here's the first commandment, and here's the second commandment. There's certainly room for dividing them in different ways. Martin Luther did it this way. That's the way I'll do it. Commandment 5, you shall not murder. My PowerPoint slides have a little something for everyone. For my intelligent viewers, I have data. And for the morons, I have manipulative anecdotes. Which reminds me, did you hear about the boss who died because he didn't praise his employee? Not so subtle. No, you can't talk to my boss. He's on another line. Now, obviously, we recognize that we wouldn't murder somebody in the context of software engineering. But how can the commandment relate to the attitudes and actions of the individual, especially in the context of software engineering? Oh, T. Okay. Not T, it's W. Okay, ignore that. Let's review a couple of things we said at the very end of Unit 1, because they are important. And we're going to see this in this unit also. And that's the importance of planning. Someone you're unaware of, the 34th President of the United States, Dwight David Eisenhower, had a famous quip. And it went like this: plans are useless, but planning is indispensable. You're saying, that doesn't seem to make any sense. If plans are useless, why would you plan? Plans are useless, but planning is indispensable. What President Eisenhower meant was, plans are going to change. I doubt that the plans you made for this semester have all come off without a hitch. I doubt the plans you made for your academic career at Concordia Irvine have come out just exactly as you thought, even before you set day one as a freshman on campus. Things change. Sometimes people say, because things are going to change, we'll just, I'm not even going to worry about it. Just go with the flow. No, what President Eisenhower is saying is, you have to plan and replan and replan. Recognize the plans are going to change, but the process of planning for things, yeah, that's important. So in software engineering, to control and manage a project, what do you want to manage a project? Because that's what software engineering is, the management. To control and manage a project, you must have a plan. That plan includes a schedule. What's going to be done when? and not just saying 3 months from now, we're going to be all done. How am I going to get there? How long will requirements take? Specifications, design, instantiation, deployment, etc. That's why we have milestones. And that's why I mentioned in Unit 1 that a milestone must be measurable. If your plan is to be done soon, to be done quickly, to be done in a reasonable amount of time, that's not a plan, because none of those are measurable. To say, I'll have assignment 13 done Wednesday, October 5th, that's measurable. Milestones have a measure and a deliverable. In other words, what are you going to have done on October 5th? I'm going to have the source code and I'm going to have the executable. That's planning. So this is a repeat of the Roman numeral from last unit, estimation. But can I say some more things about estimation? Thank you. How in the world can I know upfront how much effort, time, and resources a project will take? Aren't you asking me to predict the future? That's a little fuzzy. How can I, a priori, just means upfront. How can we know a priori how much effort, time, and resources a project will take? Well, the alternative is to say, we have no clue, so you'll get it when we get it. And that usually doesn't work. If you're not familiar with Yogi Berra, catcher for the New York Yankees, they're the ones that wear pinstripes there, also known as a great American philosopher. He had all these sayings, these yogi-isms. And this one is apropos. Prediction is very bad, especially when it's about the future. Oh, you know, he had, it's deja vu all over again, which is the same thing again, you know, and it's not over until it's over. Okay, all right. Prediction is very bad, especially when it's about the future. Now, why is that? Let's go back to that Fred Brooks article that you read, the first article from Fred Brooks that you read last unit, The Mythical Man Month. In that article, Brooks mentioned there's a big difference between effort and progress. And I think you know this too. You might put forth a lot of effort into trying to do, let's just pick a hypothetical thing like homework assignment 11. You may have put forth a lot of effort, but you didn't get seemingly anywhere. It's not working. I can't, it's not doing this. It's not doing that. I can't, but yet you spent a lot of time. That's the way informational tasks are. There's no direct correlation between effort and progress. Now, Brooks started off that article. Make sure you understand that in some cases, effort and progress are linearly related. More effort, more progress. That happens in what I'm going to call traditional tasks, like manufacturing, or Brooks's example, I think, was picking apples. Or did I just make that up? Imagine that you own an apple orchard. I know you likely do not. But let's say that you know that it's going to take 1 week to pick 1 acre of apples. Now you have 10 acres of apple trees and the crop is coming in and you know you can't wait 10 weeks. So if you hired more people to pick apples, would you get it done faster? Yes, right? If you had 10 people, you could say, you take that acre, you take that acre, you all do it in parallel simultaneously, and you're done in a week. Traditional tasks, effort and progress are related linearly. So manufacturing, I mean, this was the assembly line idea, right? You want to make more Model A's? Well, you just add another line and more people, and guess what? You get more Model A's coming out the end. Effort and progress are related linearly. More effort, more progress. More workers, more apples, more workers, more Model Ts. Oh no, sorry, those are Model A's. Software development is different. It's not like that at all. Effort and progress are not related linearly. Software development is different from traditional tests. Software development is not a manual labor process. It is an informational, intellectual process. So in software development, as we said up front, and you know full well, effort does not equal progress. You might beat your head for a long time and get nowhere. Why aren't people and months interchangeable in software development? We're getting close to the mythical man month. Why? In other words, if I want to pick more apples, more people. More cars produced, more people. But I can't do that in software development. A couple reasons that I think you can see with what you understand right now about coding and software engineering. The task of software development might not be partitionable due to its sequential nature. Can you test code at the same time that you're writing requirements for the problem? Not really. Not really. You can't test before you design. You can't test before you have the specs. You can't test before you do it. Some of these things are sequential. We can't say, okay, 6 software engineers, you do requirements, you do specs, you do design, you do standardization, okay, got 1 week, go do it. Doesn't work that way. Can you test the software today? No, I'm making major changes Tuesday. You could test the current version. I wish people wouldn't slap their foreheads and say, ay, 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 every time I talk. Exactly. And the other one, and a lot of you picked up on this when you read the Brooks article, is this concept of communication overhead. If we're picking apples, you don't have to do a lot of communication as you're doing it. On day 1, for 5 minutes, you say, you go there, you go there, you go there. That's it. Pick the apples. Not so in software engineering. Communication overhead explodes as the number of software engineers increases. The more software engineers, the more lines of communication. 2 people, 1 line of communication. 12 people, thousands of lines of communication. The very end of Unit 1, I mentioned 2 possible approaches to estimation. One possible approach is the heuristic approach. A heuristic is a guideline. A heuristic is a rule of thumb. A heuristic is, you know, this feels right. It's certainly not an algorithm. The heuristic approach is based upon experience. A senior engineer, a designer who's been there a while, will say, you know, this problem seems similar to this problem we did 2 years ago. I'm going to guess it's going to be just a little bit more. So I'm going to say it's going to take us 10% more time and resources than it took this previous. It's based upon experience. The other approach is an algorithmic approach. The algorithmic approach uses an algorithm, uses a mathematical formula. And I told you an example of one. Oh, it's still coming. Okay. There's a mathematical formula. We'll see one in a moment called Kokomo. Now, you know that algorithms work by giving them data. They'll process it arithmetically or logically into information. So what's the data that I'm going to give this estimation algorithm? Well, many algorithmic approaches to estimation take an input called LOC, lock. It stands for lines of code, lines of code. If you can estimate how many lines of code will be in your finished product, you input that to the algorithm will tell you how long, how many people, how much effort. COCOMO, COCOMO, you don't have to remember what the acronym stands for, constructive cost model. COCOMO does just that. If you can estimate the number of lines of code that'll be in your finished product, you put that into a couple formulas, and COCOMO will tell you how long it'll take to develop and how many software engineers you need in the process. So all this is saying is lines of code go into COCOMO, and the two things that come out of COCOMO are man months. Yeah, actually that place, isn't that out the Florida Keys? Isn't that a K? Maybe I'm thinking about the city in Indiana. The city in Indiana, there's a Kokomo, Indiana. That is a K. Man, the Florida Keys are really okay. Is man months, and TDEV is total development time. So how many people do you need on this project? And how much elapsed time is there? Oh, it is. Okay, good. Great work on the schedule, Johnson. Now cut the development time in half and we'll be in business. What makes this funny and not funny at the same time for a professional software engineer is this is oftentimes what happens. You spend a lot of time and effort coming up with a good schedule. And then management says, nope, no way. Sort of like a professor, right? You say, I'm going to need 3 weeks to do this. And I say, no, you get 1 week. Great work. Now cut it. This is the frustrating part sometimes of software engineering. All right, let's really do it. You ready? First major point in Unit 2. Let's overview design. My picture here is supposed to indicate that getting from idea into implementation is actually a very messy process. Design is not easy. Design is hard. Design is repetitive. Design can be messy. Design is how we get from idea to implementation. The design phase is how we move from the idea generated in requirements and specifications into an actual implementation. Okay, sorry. I just like the word. It's kind of fun to say. Instantiating. Instantiating the idea. Practice with me. Impress your friends. At the next party, hey, what'd you do? Oh, I instantiated Sprint for them. What? Here's the key word associated with the design phase. How? How will the product solve the problem? Keyword associated with the design phase. How? Requirements was why? Specifications was what? And now we get to the how. We've talked about a lot of computer science related things and specs, features and functions, but we didn't spend a lot of time figuring out how those functions are going to implement those features. Let's do that now. What's that mean? What's our focus as a computer scientist? That means it's time to plan the algorithms and the data structures. It's time to plan the algorithms and the data structures. We're going to use a technique called PDL, Program Description Language. Another older name for that is pseudocode. Pseudo, P-S-E-U-D-O. Pseudo means it's Greek for fake or false. Pseudo code is a similar thing. Now, maybe you have done some of these things in other coding classes. We're going to look at that in this class too. But you don't jump directly from idea into implementing the code. First, you instantiate the design. Think of design this way. Think of design as the blueprint for the code. No licensed civil engineer would start building a building without a blueprint. And actually, there are a number of blueprints. If you're not familiar with the term blueprint, it is just the design for something. Look it up. They're called blueprints because historically they were the process that produced them, was a reverse process. So you had white, drew with blue ink, but then you ended up with blue background and white. Okay. Do you think that One World Trade Center in New York City, do you think that they just started pouring concrete and throwing steel up there? I'm talking about the revised one, the 2016 version. Yeah. No. They spent an enormous amount of time coming up with the design. This should not be a surprise, but in actual fact, the hardest aspect of the entire software development process is design. Doing design well, doing design correctly is hard. A competent programmer could implement the product from the design. In other words, you're already good coders. I mean, Professor Tallman, you've already taken some classes, you can code. And that's what he's done. He's told you, hey, here's the specs, go do it. If I handed you a design document, it would be so detailed that you'd be able to just immediately start writing code. Now, implementing the code isn't like falling off a log. There's still some things to think about. So it's still mental effort. But you wouldn't pause and wonder, hey, do I need another method here? Or, gosh, I wonder what kind of struct should be done. That's all detailed in the design. I seem to have left my purse at home. I won't be able to pay you. I put the curse of competence on your firstborn son. That doesn't sound so bad. Years later, I need a little help. I always mean. The curse of competence. Okay. All right. The Great Wall of China was designed to keep Chuck Norris out. It failed miserably. Okay. I was trying to find something with design and Chuck and, oh well. Will you give me an E for effort? Design could be good. Design could be bad. What does it mean, good design? Good design has several characteristics. Let's talk about 4 today. Good design, first of all, means the design meets the specifications. The transcendental here is the ideal of truth. The design embodies truth. Meet specifications? If the specifications say this button will undo the last data item entered, meaning it will reduce 1 from the count and reduce whatever that value is from the running total, your design does just that. Your design takes the specifications and instantiates it in PDL. It meets specifications. It's true. So let's say we created this app here, the financial calculator app. If the user types in a principal amount and an interest rate in years and clicks process, the design behind the code did actually compute an accurate, truthful monthly payment and total interest. If it does its job, then that's one aspect of good design. If it actually solves the problem correctly, that's one aspect of good design. So if in your Shim calculator app, I would love to tell you that this wasn't a real one, but it was a real one. I typed in a single value, 0.19. Press calculate, said total shim weight 6.15, number of shims 1. I said, okay. I said, I wonder what happens if I print that. Print that, running total 5.9 shim, 6, shim count 5. Bad design. The algorithms were totally honked up. Colloquial phrase, they were incorrect. Bad design. I guess I just have too many of these, but you could probably figure it out, right? I mean, you're using an app on your phone and it says, okay, I tried to enter a goal. What's your savings goal? As soon as I clicked enter, it said invalid digital signature. First of all, I wasn't expecting a digital signature. I never entered one. It certainly doesn't want that for my savings goal, right? Bad design. You remember a few years ago, Apple Maps had a little issue. This is what some freeways around me looked like. I hardly imagined what things around you might have looked like. At Apple, we strive to make world-class products, deliver the best experience. With the launch of our new maps, we fell short. Yeah, they kind of fell short. Bad design. While we're improving maps, why don't you try Bing? Okay. Second aspect of good design. Number one, meet specs. It's truthful. But beyond that, not only does it give an accurate answer, it works well. It works well. That's the transcendental known as goodness. Truth, goodness. Examples. You may have your favorite to-do list app. I use this thing here. I don't even know what it's called. But to me, not only can I understand what all things are, but they're in a place where I'm expecting them and they do what I want them to do. I can easily rearrange things. I can easily reprioritize things. I can look at things in 12 different ways. It is good design. I wanted to use automotive examples for all these things. I won't. But if you've ever been in the driver's seat of an extremely well-designed automobile, all the controls are where you expect them. And you can see everything. Yeah. Okay. I always pick on, I guess I can get away with it because when I do this at my home university, then somebody always goes, tells the administration, and I got to explain why I'm, picking on whatever. When we go to you have a my.cui.edu, we have a my.cuw.edu. And when you launch it, you always have to click here. It doesn't start with the focus in the field. You have to type in your username and password. Why should I have to click here and then type? Why not put the focus there? Which is exactly what I asked you to do in a previous sprint. It's not hard, right? You saw it. It's just an attribute on the form. It's a, property on the form. Where's the focus go? Now it works, right? I mean, when I talk to my IT people, they say, what's your problem? You can log in, can't you? Yeah, I can. Why should I always have to click there and then type my username and password? What's the point? Bad design. It's not good. Okay. Oh, this is one of my, you have a similar, I don't know if you see this in the stuff that you do, but I mean, at our thing, if I want to get to fall 2022, I've got to scroll through like 12 years of stuff and get up to whatever I'm looking for. How about it defaults to the current semester? There's an idea. All right, this is just, okay, I'm sorry. I shouldn't pick on these things. So, meet specifications is truthful, it actually works. Number two, not only does it give correct output, but it works well. It provides a good user experience. It seems like a meaningful, logical extension of what I was expecting. A third quality of good design is aesthetics. It is pleasing. This is the transcendental of beauty, truth, goodness, beauty. It looks nice too. I like this timer. This is cool. Yeah, I like that. I don't like that. I don't like that. Now, you're thinking, well, isn't this just in the eye of the beholder? I mean, you like this and you don't like that. No, there are actually some legitimate, identifiable issues in each of these. It's for a course in user experience. We'll do a little bit of that later, but yeah, trust me, that's bad. That's better. At my university, for my MEC1 courses, I have to do attendance. I use a system that my IT people call automated attendance tool. It is not automated in the least. I have to go in and manually click, run through 3 different things: absent, present, or some other thing, like they came late or they had an excuse or whatever. Now, I didn't show you the names because I don't want to have identifiable things with this, but the names are in light blue and it's really hard to read. And beyond that, the names are in a field that's like, oh, maybe 12 characters wide. So they always wrap, but they're split usually right in the middle of the last name. And I can't expand that field. I can't say, hey, can we make that field like 25 characters wide? I mean, I have a number of students from India and their names are really long. I like to make that field 30 characters. I can't. It's 12. Some names wrap twice. I can't. That's just, okay. You see, it works, but man, it's not pleasing at all. Okay. If you're unfamiliar with these are urinals. You'll find them in male restrooms. You might not be able to tell what's happening there, but you notice where the fire escape goes? Right into a chain link with barbed wire enclosure. So you might be out of the burning building, but now you're trapped right next to the burning building. Okay. All right. Okay. This was an actual product. You see, they didn't put their own company on it. They just left it with sample text. Well, okay. I thought they were funny. Another aspect, final aspect for today of good design. Good design is robust. The definition of robust is can deal with the unexpected. Robust can deal with the unexpected. Computer scientists, unlike coders and programmers, have to think ahead. what might happen when somebody uses my product. And I don't mean just what I intended them to do. Those are called intentional consequences. I also mean, what are the unintended consequences? What could go wrong? How might my design fail? And what happens if it does fail? We want robust products. That's why in the very first thing of add numbers, I introduced try catch. If it's not what's expected, don't just have your code drop dead and append to the operating system. Catch it, trap it yourself, do something. Think ahead. What can go wrong? How can I mitigate it? How could I prevent it? And if I can't prevent it, how can I alert the user? And fail gracefully. If you look online at Blackboard, and let's go do that, you'll see assignment 13. Oops. Wow, do I have Blackboard set up here? Oh, I do. Look here. Good. Set it so what I see, what you see is what I see, and vice versa. So now again, new link here. We're done with Unit 1. We're now in Unit 2, the implementation of software engineering. Their readings. We just had a test, and I know we didn't do a quiz over week 5 reading. We may not do it in week 6 either. We might get back to this, but we just took a test. So let's take a little bit of a break. Outline for today, C and CS5 and assignment 13. Sprint 4. First of all, ensure it meets all Sprint 3 requirements, and then add the following 2 major things. Number 1, last time you did a save and print feature, I wanted to be on the menu. I think I said that, but it might not have been in the assignment. So I just wrote that. If you didn't, no problem. No points were lost. But now I want a menu item that says save and print. Before, when you selected it, all it did is brought a pop-up. It just pretended like it printed. Now, I want you to actually create a file on your storage, and that file will contain a date and time stamp, the day and time the file was created, along with the weights in the bundle and the count. So exactly what you put up other than day and time on that pop-up window. We'll talk about this in just a minute. I'll show you some code to get you started. Second one, validate the undo feature. Previous spec said undo only has to work one time. What if the user clicks undo again? Well, a lot of the code did some pretty weird things. Some of you, however, actually thought about that. So a couple of folks had multiple level undos with a struct. Wow, good for you. Amazing. I want you to do one of 2 things. Either allow for multiple undos, which is harder conceptually, harder design. In other words, let's say I typed in 5 things and I noticed the last 2 things I entered were wrong. I want to hit undo twice, remove the last 2 things, and then move on from there. By the way, be sure that your undo not only changes the feature, the outward expression, what the user sees, but also internal to your variables. Some of your code would, fall back on the display, but then when I went forward, it still remembered either the count was off, or the running total. It didn't really remove it from the running total or the count. So you have to do 2 things here. That's hard to do. Or less difficult is to only allow 1 do and not multiple. Either gray out undo, so the user couldn't select the button after they'd done it 1 time. Now, if they enter good data, then the undo button appears again because they can undo that 1 level. Or don't worry about graying it out, but if they press it a second time without adding things, you just pop up a message, sorry, can't do that. Only one level of undo is implemented. If you didn't quite do this in sprint 3, do it now. Give me good help on the help menu. Now, there is a document here. Write to file code. Oh, darn. Did I bring, hopefully I brought that up already so I don't have to deal with it. Yeah. Okay. I've got a couple references here, and I would encourage you to go to those references and investigate what's there. By the way, I'm convinced that you can find the answer to any question dealing with a Microsoft product at a Microsoft website. The hard part is where? In all those petabytes of data. Yeah, that's a little too much, but they've got a huge amount of data. The answer to any question with either C# or Visual Studio is there somewhere. Hard to find sometimes, but it's there. Okay. Now, here's some code. What this code, I wanted to show it to you. I had my IT support. I think I told you that they finally were able to get my Windows license properly. But now I got another little issue with parallels there. So things are not working well. It works. It's just slower than normal. So here's the code. I'm going to encourage you to just try this code out. Now, I was going to do it with you. If you're wondering what this says, initially, I was going to have you just enter this code without this compiler directive. Using system is there, but not using, you just type in this code, you'd go to compile it, and you notice there's an error. What? The error says, are you missing using a directive or assembly reference? Yeah, we're missing a directive. So that's why this says, now add using system.io. You don't have to do it. Just add this originally, do this, and see what happens. Note a couple things. Here's the string, first line, second line, third line. And of course, the way C# works is this will actually be on separate lines. Now, this, I want to find the document path, my documents in there. That's how to do that, because I'm going to ultimately write this file to my documents. You can experiment, you can put it someplace else. Here's how to write it using StreamWriter. Other ways, but StreamWriter is a good way, and I got some documentation, I think, at the end here on here. StreamWriter, go there, all you need to know. Okay, run through 3 times, output it to the file, we're done. All this code has on it, I think I said here somewhere, there's just, to test it out, just create a simple form that has a single button. That button says write. And here's the code behind the write button. The comments are just so you can see what's there. You wouldn't need them. And then when you're done, look in your documents folder for a file called writelines.txt. Open it up with your text editor, and you should see first line, second line, third line. How does this help? Because this is what you need to do in the next sprint. In sprint 4, assignment 13, you need to create a file. Here's how to create a file. Now, the second one has 2 different buttons on it. A write, what write does is same as before. You'll have the same thing, that code there. Notice write picked the file name for you. The user didn't do it. Writelines.txt, that's what it's called. Sorry, that's what it is. What if you want the user to specify the name? Well, that's the code behind save as. Here we'll ask the user. It brings up, guess what? The classic standard Windows save as. And then you'd be able to actually spec a name, spec a location, click save, and it'd be there. For this sprint, you don't, save as would be better, But you don't have to do that. There's a little more complexity here. And there's a couple things to think about. So you can just do it. But if you just do this, be sure to alert the user. Tell the user, we save this data to a file called blah in location blah. Tell the user. Don't make the, well, I wonder where that went. Good. I would encourage you to just create a new project, throw this code in it, and get it to work independent of any of your other sprint code. Make sure you see what's happening with all this, and then you can add this as another method to that menu item on your sprint. Ooh, that's fun, huh? And then it's the same thing that you've seen before. I want you to rename your executable. Well, I was going to do it a different way in this unit. We just all use get, but this is fun. This is fun. I like this. And once I'm absolutely convinced that everyone is able to do this, then maybe we'll do it some other way. Rename. If you're having trouble doing this, be sure to turn on file extensions in Windows. Without the file extensions, you'll mistake a config file for an executable. Or try to rename it, it won't rename. You upload it, it doesn't run. Yeah, life is bad. Check out some of the, either send me a message or check out some of the course casts in the past where we've gone through this, and your source code. For those of you that are giving a good initial comment, and a good initial comment includes your name, the date, and the purpose of this code. And the purpose is not just to add numbers anymore. That was good enough for the first one. There are a lot of features here. Explicitly state the features. This is important. So I keep saying, please do this. Now I'm going to get serious and lob off if you don't do it. The comments in the code we're going to come to after a little bit. A good comment in line explains why you're doing it. If your comment is something like, I'm adding now, don't. I know, I can see. Why are you doing this? It's especially important to have inline comments in two cases. Number one, at the beginning of any module. So any button, any form, any method within your code, have a comment. Even if you think it's painfully obvious, even if you've named your button add, that's okay. Go ahead and do that. People are expecting that. And the second place for inline comments is by any control structure, by any selection, by any if statement. Why? Why are you doing this? By any loop, by any repetition, by any method or procedure call, by any recursion. Comments there are very helpful. Now, here's the problem. You know what the code does, or at least you know today. But somebody who comes and reads your code later, it will be very helpful. And you know what? It will also be helpful for you several weeks later. You're going to say, yeah, I'm going to remember what this does. And you know what? No, not really. We honestly don't remember what it does all the time. CNCS 5, so just like you've seen with the other ones, fifth commandment, strives to maintain a cool and calm composure in every circumstance. Explain how this attitude is related to the fifth commandment. Yeah, how do you get that out of there? And my hint is always take a look at the positive aspects of the commandment. Good. Any questions perhaps about assignment 13? Assignment 13 is due 1 week from today. Next Wednesday, October 5th, maybe. I hope that my machine will be usable enough that at least I can demonstrate some of that reading to a file to you at that time. Don't wait. If you start now, then if you have questions, you can ask them next time. And trust me, if you have the question, so too do a number of other people. Here are the two major new features: save and print, and do something with undo. And yeah, there's that right there connected to the assignment is that document with how to write to a file. Any questions about that strike you right now? Good. Wow. And wait a minute, we still have time. I think we're ending early a lot of the time. Professor Tallman is probably asking you, does he end class early? To use up the time, we could all sing the Beach Boys song, Kokomo. Off the, all right. Thank you so much, folks. We're done. I guess the final thing I said, I mentioned this last time. My stated policy is I don't want to accept late homework. You send me a message, I will consider it. I've talked to a couple of you. Yeah. Just please give me a little break on this. You know, when stuff comes in after the fact, it'd take me a little while to get back to it. So yeah, let's do it. If it's late, it's not going to be worth full credit, but it's better to get some partial credit rather than nothing at all. So if you haven't already talked to me about that and you're in that boat, then let me know. So with that, let me say thank you so much for your rapt attention. I appreciate it. Have a good day. Looks like the weather might be a little nice for the weekend, right? Drop into the high 70s. Good for you. Enjoy it. And then I will see you on Monday.